Hi everyone, welcome to AWS API Gateway tutorial. I am Arockiadooss. In this tutorial, we will learn about AWS API Gateway, its use cases, key features and concepts, steps to integrate with AWS Lambda, create an API Gateway REST API, test the API, and finally clean up the resources we created to avoid unnecessary costs. Now, let's go into the details. First, API Gateway overview. Before we start learning about API Gateway, first we need to know what is an API. API stands for Application Programming Interface. That is, it's a set of definitions and protocols that enables software application to communicate with each other to exchange data, features, and functionality. For example, you have a currency exchange rate app on your phone, and how does it show you the daily exchange rate on your phone? It works this way. That is, the app communicates to foreign exchange rates system, which contains daily exchange rates via APIs and outputs the daily exchange rates on your phone. Now, coming to Amazon API Gateway, it's a managed AWS service for creating, publishing, maintaining, monitoring, and securing REST, HTTP, and WebSocket APIs at any scale. Next, API Gateway use cases. One of the main use cases of API Gateway is we can create REST APIs using the API Gateway. First, let's see what are REST APIs and how API Gateway supports in creating REST APIs. REST stands for Representational State Transfer. The main feature of REST API is statelessness. Stateless means that servers do not save client data between requests. REST defines a set of functions like get, put, post, delete, etc. that clients can use to access server data. Clients and servers exchange data using HTTP protocol. An API Gateway REST API is made up of resources and methods that we'll see in the hands-on demo. A combination of a resource path and an operation identifies a method of API. Next, create HTTP APIs. Using API Gateway, we can create HTTP APIs. HTTP APIs enable to create RESTful APIs with lower latency and lower cost than REST APIs. We can use HTTP APIs to send requests to AWS Lambda functions or to any publicly routable HTTP endpoint. Also, the HTTP APIs have less features in comparison to REST APIs. Next, we can create WebSocket APIs. What's a WebSocket API? A WebSocket API makes it possible to open a two-way interactive communication session between the user's browser and a server. In a WebSocket API, the client and the server can both send messages to each other at any time. We can use API Gateway WebSocket API to build secure real-time communication applications without having to provision or manage any servers to manage connections or large-scale data exchanges. Some of the use cases are build real-time applications such as chat applications, real-time dashboards, and real-time alerts and notifications. Next, let us see some of the key features of API Gateway. API Gateway supports stateful API such as WebSocket and stateless API such as HTTP and REST APIs. Next, highly secure mechanisms for authentication and authorization. Using IAM, Identity Access Management, we can create resource-based policies to allow or deny access to APIs and methods from specified source IP addresses or VPC endpoints. Next, Lambda Authorizer. The Lambda authorizers are nothing but AWS Lambda functions through which access to REST API methods can be restricted using bearer token authentication, as well as information described in headers, paths, query strings, stage variables, and so on. Next, using Amazon Cognito user pools, we can create customizable authentication and authorization solutions for the REST APIs and also control who can invoke REST API methods. Next, deploy the API with a canary release deployments. First, let us understand what is canary deployment. Canary deployment is a pattern for rolling out releases to a subset of users or servers. The idea is first, the release is deployed to a small subset of servers, test it with a subset of users, and then roll it out to the rest of the servers. If the canary deployment fails, it only impacts users on the subset, while the users on the rest of the servers are not affected. Using canary deployment, we can deploy a bug-free API to production. Next, logging and monitoring of API usage and change by CloudTrail. API Gateway is integrated with AWS CloudTrail, which logs all REST API calls for API Gateway service as events. The CloudTrail log stores the details like the request made to the API Gateway, the IP address from where and when the request was made, and so on. Next, CloudWatch metrics and logging. CloudWatch metrics collects and processes raw data from API Gateway into readable, near real-time statistics. The API Gateway metric data is automatically sent to CloudWatch in 1-minute periods. Next, API Gateway supports custom domain names. What are custom domain names? Custom domain names are simpler and more relevant or meaningful URLs that can be provided to the API users. By custom domain names, we can change the default base URL to our own custom URL. For example, the default base URL https://api-id.execute-api.region.amazonaws.com/stage can be changed to meaningful custom URL like https://itskillmaster.com/customer-info and so on. Next, integration with AWS WAF. We can use AWS WAF, that is Web Application Firewall, to protect the API Gateway REST API from common web exploits such as SQL injection and cross-site scripting attacks. Next, integration with AWS X-Ray. By integrating with AWS X-Ray, we can trace, analyze user requests as they travel through API Gateway REST APIs to the underlying services. Next, let's see some of the important concepts of API Gateway. First, API deployment. An API must be deployed and associated with one or more stages such as dev, UAT, prod to make it available for the clients to use it. Undeployed APIs will not be available for clients. Next, API developer. API developer is the AWS account that owns an API gateway deployment. For example, a service provider that also supports programmatic access. Next, API endpoint. It's a host name for an API in API Gateway that is deployed to a specific region. The format of the hostname is api-id.execute-api.region.amazonaws.com. Next, let's see the three types of API endpoints such as edge optimized, private, and regional. An edge optimized API endpoint is the default hostname of an API gateway API that is deployed to the specific region. A CloudFront distribution is used to facilitate client access from across AWS regions. API requests will be routed to the nearest CloudFront point of presence for low latency. Next, private API endpoint. An API endpoint that is exposed through interface VPC endpoints. It allows API consumers to securely access private API resources inside a VPC. Private APIs are not accessible from the public internet and can only be accessed using VPC endpoints. Next, regional API endpoint. Regional API endpoint is the host name of an API that is deployed to the specific region and intended to serve clients such as EC2 instances in the same AWS region. Next, API key. It's an alphanumeric string that API gateway uses to identify an app developer who uses REST or WebSocket API. API stage. An API stage is a logical reference to a life cycle state of the API. For example, the API stages could be dev, UAT, prod, and so on. API stages are identified by API ID and stage name. Mapping template. It's a script in Velocity template language that transforms a request body from the front-end data format to the back-end data format, or that transforms a response body from the back-end data format to the front-end data format. Next, usage plan. A usage plan provides selected API clients with access to one or more deployed REST or WebSocket APIs. It can be used to configure throttling and quota limits which are enforced on individual client APIs. Prerequisites. For this tutorial, you need to have an AWS account and you can create a free tier account, and you can find the creation link in the description. You also need to have an IAM user with required privileges such as to create API gateway, Lambda, CloudWatch, log group, and so on. If it's difficult to spot out the specific privileges, for this tutorial, you can assign administrator access managed policy to the IAM user. Next, create and test API gateway API. So for this, first we need to have an Lambda function. So from AWS console, we will create a Lambda function using Python language, which will act as the backend service for the API. The Python program is provided in the description and you can use it for this tutorial. Also, I have created a detailed tutorial on AWS Lambda, and if you are interested, please watch it and learn. I have given the link in the description. Next, we need to create an API. So we will create REST API in AWS console, then create resource named customer and a get method which will be integrated with the Lambda function. And finally, we will deploy and test the API. Before deploying the API, let us test it from the AWS console. Once it is successful, we will deploy the API to generate the URL and test it from the web browser. Now, let's log into AWS console and do the hands-on demo. Now, I have signed into my AWS account. So, first let's create the Lambda function. So, for this, go and search for the Lambda service. select this. So select the region. So click this create function and it will go to this screen. So here I will create a Lambda function from scratch. Give the Lambda function name. So, and I will use Python. So I will select the Python 3.13 as the runtime. Next, for permission, so it needs a service linked role. So I'll create a role for the Lambda function. Next, we will not add any additional configurations and click create function. So this will create the Lambda function. So in the meantime, I have a Lambda code. So copy this code and paste in the Lambda function code editor. So we can see that now the Lambda function is created and this is the default code that is generated. So select this and override this code with the my code. So just I will give you a simple explanation of this code, what it is going to do. So here, if you watch my AWS Lambda tutorial, you will find I have clearly explained about the event and the context object. So this event object contains the data passed into it. So here, first I am printing the event, whatever data it is passed from the API gateway. Next, here you can see some of this. So the API gateway is passed with, if the API gateway is passed with query parameter, so it checks if the query parameter is found and if the query parameter has the ID string, then it assigns that query parameter ID to this field ID. So if that key is not found, it says query parameter ID is missing. Then from the API gateway, if the query parameter is passed, so it will check if the passed ID is C001, then it will return this response. If it is C002, then it will return this data as the response. If query parameter is other than C001 or C002, it will say ID not found. And in the response, you can see here, so this is the format you need to follow when returning the response to the REST API. So here status code equal to 200, so I have put it as a success and I am converting this data to the JSON format. Then I am adding the header as application or JSON. So this is the simple explanation of the Lambda code that will send the response to the API that will be called from the API gateway. Now, so let's deploy this function. So deployment is successful. Now just test whether it is working successfully or not. So for this, just create a test event. Okay, I'm giving Lambda. So here I am giving, for example, ID equal to C001. Save. So this is just to check whether it is the Lambda is executing successfully without any error. Now click this test and select the test event, and we can see here the Lambda has executed successfully. Okay, so now we have created the Lambda successfully. Next, go to the API Gateway service and create the REST API. Now I have opened another tab. So here I will search for API Gateway service. So select this one. So as I have explained in the theory part, we have four types of APIs. So here HTTP API, WebSocket API, and REST API, and REST API with private. So here I will go for REST API. So click this build button and will come up with these options. So whether you want to create a new API or clone existing API, import API, example API, and so on. So for this tutorial, I will go with the new API. So here I will give, so I will say give the name as customer API, and I explained the API endpoints. So there are regional, edge optimized, and private. So I will go for the regional API. So click this create API. So we can see that now the API is created successfully. Next, we need to create a resource. So click this one and create a resource. So this will be the path for our API. So here I will give resource name as customer. Then, so here cross origin resource sharing. So I will not use this for this tutorial. So click create resource. So now the resource has been created. Next, we need to create a method get, post, put, delete, and so on. So click this create method and so select the method type, which one you want. So I will go for the get method. So which will, and I will choose here the lambda function as the integration type. So here we have various types. So we can go for HTTP or we can use MOOC. So only the API will create and it will give you a MOOC response. Or we can use other AWS services and VPC link. So for this tutorial, I will go for Lambda function. So here, since I have designed the Lambda function as a proxy integration, so I will enable this one and Lambda function. So my Lambda function, I need to choose AP Northeast one. So you need to select your lambda function region. So once you select the correct region, the lambda function will be popped up here. So select the lambda function and other things I will leave it as default settings. So request settings, query string parameters. So I can add a query string here. For example, say okay ID required. Then I can add a HTTP request header if you need or request to body and so on. So for this tutorial, I will just send a query string parameter and create the method. So now we have created the API. If you can see here, we can see here that it has the method request, then integration request. So once the API is invoked, it will call this integration request lambda. Then the lambda will process the data that is passed through the API and return the response, and that response will be returned to the client. So as we have created the API and integrated with the lambda, now let's test the API. So here you can see that here is the test button and click this. So query string I will pass ID equal to C001. So now let's test our API. So we can see that the API has returned the responses ID C001, name equal to Arockiadooss and email equal to customer001 gmail.com. So if you go to the Lambda function, see if the query parameter is, if the ID is C001, it will return this value. So we can also check our log. So click this monitor and go to the CloudWatch logs. So it has created the log stream and we can see the output. So what this API has passed. So here first we see that ID C001. Okay, this is the first execution. So we need to go for this execution. So it starts from here. This is the API execution. Here if you see that this is the event object. So here we have put print event. So it has printed the event which is the complete set of details displayed here. So here if you see, okay, so you see the query string parameter is passed here and the other details. So like header, path and all other details are passed from the API gateway are logged here. Now, okay, let's test with another one. Say, for example, I'm giving now C002. So, let's see, it should bring the customer ID 2. So, let's click test. Yes. So, now we passed query string parameter as C002 and it has brought returned the response according to the ID GC002. Now say I am not giving, I am giving 3. So it should return no ID or not found. You see, so it returned ID is not found. So based on this, if the ID is other than C001 or C002, it will return ID not found. So it's clear that our API gateway, the REST API that we created, has successfully executed and it invoked the Lambda function, and the Lambda function in turn processes the data and returns the correct response. So we have tested our API from the AWS console. Now let's test it from the browser. So that is, we need to deploy this API and generate the URL to test it from, or to test it from the public internet. Now we have this button, click deploy API. So here it will ask for a stage name. So I have already explained about the stage in the theory part. So here, whether you want to release it to dev or prod or EAT and so on, you can give the stage name and click deploy. So the API has been successfully deployed and the dev stage has been created. Now let's go to our get method and copy the URL and test it from the browser. So copy this URL and paste it here. Check it. So since we didn't pass the query parameter ID, so it says not found. So it's returning this response. Now let's invoke with the query parameter as id equal to C001. So now it should return the response for the C001. Sorry, I missed ID, so I put only I. So we can see that the response for the ID C001 is returned. Now let me pass ID C002. So we can see that the response for the ID C002 has been successfully returned. So we have now deployed the API and tested it from the browser, that is from the public internet. Now, as we have successfully created a REST API and integrated with the Lambda, sending query parameter, and based on the query parameter, it returns the data from the Lambda. Next, let's clean up the resources that we have created so that we don't incur unnecessary costs. As you know, for the API gateway, so we integrated with a Lambda function. For this, a CloudWatch log group and an execution role has been created from Lambda and API gateway. So we need to delete all these resources to avoid unnecessary costs. So now let's go into the AWS console and delete these resources one by one. So first let me go to Lambda, monitor, and click view CloudWatch logs. So as we executed multiple times, the Lambda has created two log streams. So select all these and click delete. So this will delete this. Click refresh button if anything is created. Okay, so we deleted the log stream. Now let's delete the log group itself. So select these actions, delete log groups. So click delete and it will delete the CloudWatch log group, and which is created by the Lambda function. Now let's go here and click once again to make sure that the log group has been deleted. So you can see that an error occurred while fetching index policy. So that means the our Lambda customer API Lambda log group has been deleted. So, fine. So next, let's delete the IAM permission. So for this, click this configuration and go to permissions. Here we can see that role, execution role. So this role name, so just click this one. It will take you to the IAM service, and here we can see the policy created. So select this. This is the policy that has been created for Lambda. Select the click delete. So copy and paste the role name and it will delete. So role deleted. So the role has been now deleted. Now as you can see here, so it has created a role for our API Gateway also. So select this AWS service role for API Gateway and delete it. So here just copy the name, full name, and paste it here and click delete. So it will delete that role. Now we have deleted the CloudWatch log group and the IAM role. Now let's delete the Lambda function itself. Let's go to the Lambda service, select the Lambda function and actions, delete. So this will delete the Lambda function. So enter delete and press the delete button. So the Lambda has been now deleted, and now we need to delete the API Gateway. Here go to APIs, select the API and click delete. It will ask for the confirmation, so type confirm and press delete. So we have deleted all the resources, that API Gateway, Lambda, and the execution rule and the CloudWatch log group. So we have done with our tutorial regarding the API Gateway. That's all in this AWS API Gateway tutorial. Thank you very much for your patience, and let's learn about API Gateway integration types in the next tutorial. Finally, a simple request: please like, subscribe and share to your friends if you found this video useful. Once again, thank you very much and see you in the next video. Thank you and bye.